first speaker is Frank Schubert, and with construction on Mars.
Oh, hello, everybody. Thank you. Thank you. So, in typical construction fashion, I had pretty much everything go wrong in the last day to get here. My clothes didn't arrive. Our Airbnb was booked for tonight and not last night when we got here. We went to one hotel and there was gang members had just shut up the place, so we had to go find another one. Anyway, I thought, well, that's actually a fairly typical analog for most construction jobs. So a little bit about how I ended up here. About, geez, I hate to say this, 22 years ago, this goofy guy called Robert Zubrin called me up and said, "Hey, would you help us build this habitat on Devon Island?" And I thought, free trip to the Arctic, why not? That sounds like fun. We got there and it something else go wrong. There we go. So we get there. I got to this to a Resolute Island, a Resolute Bay, and I forgot what the name of that. God, that's funny. About 25 years ago, I think I'm okay to forget the name of that island. Anyway, I got there, got checked into the hotel room, and couldn't leave for 11 days because of weather. And in the meantime, the Marines were paradropping in the habitat that's up there now. And on the last night of the day of the last drop, the Marines were standing in the same place I was, and they showed up, and I was talking to them, and they were getting drunk because they said they really screwed up. But what happened was they had a new guy on the paradrop team, and instead of hooking the drone chute up to the main parachute, he hooked the drone chute up to the payload, threw it out. The payload slowly went out without the chute, crashed, and that was there was a big pile of the habitat floors, a couple of the wall panels, and about 500 pounds of spaghetti. So the next day, the construction crew that was there came back and said they gave up, and Robert showed up that day and said, "Can you do this?" And I flew in a couple of the guys from my construction crew from Denver, and we ended up, getting the thing built that summer without killing anybody. Came close to me a couple of times, but I thought, well, it was really a hard construction job because of the way that cold it gets so cold, and then it thaws and cold, the rocks crack in thin sheets sort of, and they flip up like this. So you have to walk in between these rocks that are sticking up to 12 inches. And it's very tricky. You don't want to fall on this stuff because it's very sharp. It's all basalt. Anyway, we got that thing built, and that summer went up the next summer and finished it. And I sort of morphed into becoming a Mars Society member, getting into Mars. I was always into space since I was a kid, but I never was this close to it as all you are. So I got back from Mars, and now I'm really into it. I'm kind of getting bored with building houses and buildings. So I decided one of the things that, well, I went to work for the Mars Society for about 3 years, I think, 3 or 4 years, and we built the desert station, which is, I don't know who's been involved with that since I left, but they have done a great job. I mean, it really looks so much better than when we first built it. It was, not much there when we first built it. But the thing that I related to was that once you get to Mars, I mean, the first couple crews I would imagine are going to be scientists and and engineers. But as you start building there, you're going to have people that are specialized. Like right now, well, I was going to say, after I left the Mars Society, I started a company called Combined Solar Technologies, which I use that name because I thought I want the dumbest name I can think of, because that'll force me to come up with a cool name later. And 22 years later, I'm still working on it. I'll come up with a good one of these days. But one of the things with the Desert Research Station that I ran into was the water and the toilet situation. What do you do with the wastewater? And we went through quite a few iterations of finding ways to clean the water. And finally, I ended up building a leach field and a septic system, just like you would have in a house. And that's how the toilets work there, I think, still to this day. Now, that's not something you'll do on Mars. And I actually have an idea of what you would do with the waste and everything there. But since then, let's see if I can change this. My company, this is basically what we do, is we treat water now. And we just built a big plant in the city of Tracy, for the city of Tracy, that is going to clean part of their wastewater, not the black water or the gray water from toilets, but the industrial water that comes into their wastewater plant. And we have a zero liquid discharge system, which means that we can do inland water reclamation. Usually reverse osmosis, you don't do it on an inland application, because if you put 100 gallons in, you get 50 to 70 gallons of clean water out, and the rest is concentrated. So what do you do with that? You still have the wastewater problem. Anyway, we came up with this zero liquid discharge system that was inspired by the habitats and the work that I did, and knowing people like y'all while I was in the Mars Society, which was, it's really fun. That was a fun time. Robert and I got into it a few times, but I think you all probably can relate to that. He's a good guy. I like him. So anyway, these are what I morphed into. They look like rockets on purpose, because what's a rocket but a bunch of pipes and valves and things. So these are vertical tube boilers, which we've designed specifically for putting salty water into it, which, if you know anything about boilers, you don't do that. And in fact, if I knew anything about boilers when I started, I wouldn't have tried to do this. When it didn't work, I just thought, I didn't know you're not supposed to do that. I thought I was just doing something wrong. So I kept trying and trying. And after 2 years, we came up with these, and they work. Now, these things are not going to go to Mars. They're way too heavy, and the heat required would be a problem on Mars that I know of right now. I mean, I suppose you could try solar thermal, but I don't think we'd get very far that way. So how do you get water on Mars? That's the thing. That's reverse osmosis and cleaning the water. Well, let me take that back. That's what I thought back 22 years ago, before everybody knew there was lots of water there. We kind of suspected it back then, but now it's been proven. So getting the water, I think, on Mars is not the problem. I would have guessed that it's going to be salty and not very good. So you're going to have to clean it one way or another. In the case there, I would say the easiest way to do that would be to just use reverse osmosis, although it takes a lot of electricity. Anyway, the construction on Mars is what I wanted to talk about, because I want to I was thinking about this for quite a while now. How do you relate what we do, like the construction company I have now? What if we moved to Mars and we were building there? What issues would we run into? And what trades do you need? And how do you work in an environment that has no atmosphere, so to speak, of has radical temperature swings and big dust storms. So that's kind of where I was relating this to. How would I take my construction crew and take them to Mars. And assuming the science is well underway and there's, there's habitat modules that people are living in to start with, how do you start building more of that? And how do you build infrastructure? So, oh, one thing I wanted to tell you, this PowerPoint is really lame because this is my first draft that I did. And along with my clothes that didn't show up, a very fancy PowerPoint I had didn't show up. And then I thought, well, I could maybe do one on my computer on my laptop and realize my laptop doesn't have PowerPoint. So anyway, I'll try to get through this with these slides I have. I might end up running a little short here because there's about 20 slides I didn't have, but I'd like to take questions too from you guys at the end. So one of the things we would do if I took the crew to Mars is what tools are we going to take, right? Well, most everything is going to be made out of stainless steel or titanium or aluminum. You don't want to take carbon steel there, mainly because of the weight, but also because of the fact that it doesn't handle temperature swings that well. You would end up with any sheeting would end up getting warped fairly quickly. So what do? One of the reasons I got involved with going up to the Arctic was I went to a meeting that it was an architect that Robert had hired, and I hope he's not here. I don't think he is. But anyway, at the first meeting on the construction crew, I went to just see what was going on. These Mars guys were pretty interesting to me. And he said, well, okay, volunteers, we're going to need some tools, and, we're going to need like a hammer and a saw. And I'm thinking, oh God, this is going to turn into a disaster. So I volunteered my crews to build the interior of the habitats. And but that got me thinking, okay, what would we need? What kind of tools would you need on Mars? You're going to need hammers and saws, of course, but you're going to need welding equipment too, because anything that breaks there, you're going to have to fix. And I want to get to the welding shortly too, because that's a whole challenge in itself. Then where does the material come from that you're going to use? There's a certain amount you can bring, but you don't want to take a whole lot of stuff because of the weight. So you want to try to use whatever is there. And as I've been researching that, I came across one technique that I'll tell you about in a minute that seems to be way above everything else as far as how do you build a structure on Mars. You're not going to use steel, right? It's going to be kind of like the Wild West, where or caveman almost, you're going to have to use rocks to build this stuff. And then how many people are you going to need to build something? Let's pick a shelter for the habitats, something that either, you could go into lava tubes, but, that's going to restrict where you put your habitat because you have to put it where a lava tube is. If you want to put it somewhere interesting, in Valles Marineris or Olympus Mons, see, I still remember that stuff. You would, then you're going to have to build your own shelter. So how do you do that? One of the things I thought about was as far as manpower goes is, well, you need actual construction guys, probably the smarter guys of the construction industry, although there are a lot of really brilliant guys that just work for us that do labor stuff. Still very smart, but you want to get guys that have a bunch of skills, someone who can weld, someone who can drive a rover, someone who can fix a robot, let's say. I think robots will, if Elon gets his robots rolling and then sets them up so they can handle the temperature swings, I think that robots will be a big help on Mars because they can work longer hours, stay outside longer. So those are some of the considerations you would have: is the tools you need, where do the materials come, and who are you going to have do it. Now, in a typical construction crew, you have a lead guy, someone who knows, what the big picture is of what you're doing. And then You want your lead guy to not have more than 5 people under him, because it gets too hard to manage it for one person to be, especially if it's what we call a working foreman. So he's doing his stuff and guys are coming in every 3 minutes and asking him, what size nails do we use? How do we do this or that? So you would probably, as a minimum, I would say, to start building, you want to send about 6 construction people, 5 or 6, one engineer architect type, one lead foreman, and then 5 people to actually do the work, the lifting. And these 5 people are not just laborers. They're going to have to be highly skilled too, and know how to fix a rover, how to fix a robot, things like that. So the trades needed. These are the things I thought about this. Well, okay, what are the most critical parts that you would have to fix, and quickly if they break? Your water treatment system, that's pretty critical. Although you're probably going to have a couple 100 gallons to spare somewhere, you have to fix that very quickly. So you'd need people that were skilled as plumbers and as pipe fitters. You're going to need people who are skilled as electricians. And I don't mean computer electronics. I mean, like the wiring in this building. There's going to be a lot of that in the habitats themselves, you know, where you're going to be plugging in your centrifuge or you know, the heaters or whatever. So the electricians will have to be really skilled, and they'll have to, and by the way, you're probably going to want to have at least a couple of guys that do all this stuff, you know, 1 or 2 that understand the whole system. Laborers or robots, that would be another one. The guys who lift up the tires and, you know, change out the bolts and things like that. You want to have people like that. And they want to, I would guess you would probably want to have a robot for every one of those guys to help them out, to say if they start doing something. And you know, I bet there's someone here that knows more about this than I do, but I'm guessing there's going to be a limit on radiation. You know, if it's during the day and the radiation is hitting you, you're going to have to limit your time outside. A robot doesn't necessarily have to do that. You'll need a comms experts, you know, to keep the radios working. Maybe, as we found out at the Hab, sometimes you don't want to talk to the home base, but you do want to be able to talk to each other on, you know, without fail. You need to be able to communicate between the people, you know, the people in the habitat, the people doing the work, because things always go wrong in construction, guaranteed. Whether you're on Mars, it doesn't matter how much planning. You know, we spent 3 days planning on getting here, and sure enough, our A and B wasn't ready. Clothes didn't get here, so that kind of stuff. No matter how much you plan for it, is going to happen when people go up there. There's going to be problems, and you want to be able to communicate instantly with each other. Welders are another thing. That's what I first thought about when I thought about doing this talk, was the welding, because the metal is going to break. You're going to have parts that break, and you need to have welders that are good at the different types of materials you're going to use. Now, you know, the most common welding on Earth is with carbon steel. Like I said, I don't think that carbon steel is an option on Mars, because of the weight and just because of the way it handles cold and heat. So will be a big part of it in fixing things, fixing the structural things that break down, or the rovers. You know, most rovers are titanium and aluminum. So those are 2 things that you can weld and you can't fix. The welding rods and the welding wire, that stuff is very heavy, but that stuff, I don't see how you can't get that on Mars. So you have to take that with you. Hopefully you're not going to take a whole lot of it. So those are kind of the trades you would think about when you're building a settlement. And And on top of that, you need support for this. So you need cooks. Construction workers don't like it if you don't give them good. I remember when we were building the habitat, we'd been up for about 3 days because it's light all the time up there, and we didn't want to leave to go in for meals because it took a half an hour to drive over to the camp and then drive back, and we were running out of time. I think we only had 3 days, so we kept asking Robert, send us food. And I remember they sent a box, and I opened it up, and it was Slim Jims and almond bags. So our construction work slowed down quite a bit because you need energy, and Slim Jims, Robert thought, it's meat. It's got a lot of, grease in there. It's also, I think, technically considered a carcinogen. So I don't know if maybe he was mad at us or anyway. Yeah, you'll need to support these people too. So another issue, now this is probably an issue on Earth, although if settlement gets big enough, you're going to have this issue. Are they going to be union or non-union? No. If it's NASA, I'd say yes. SpaceX, probably not. I know Elon is not a big fan of unions. With our company right now, we have to have some of the people that are union members, which I personally don't mind. We pay them more, but generally they're better construction workers. On Mars, like with scientists or anybody, engineers, construction workers, they're going to have beefs with each other sometimes. One guy's going to build it this way and another guy's going to put it over there. You'll have that on Mars, I would guess. I mean, we've had it. I don't know if I hold a record anymore, but I spent probably 2.5 months in those habitats while I was building them and then being on cruise. And there's an example of where you start out, everybody's very friendly. And towards the end of the rotation, I was like, spaghetti again. The one thing about the unions is they have ways to resolve those kind of issues. Usually it's between management and labor. In the case of Mars, I think everybody's going to be the same. You won't have that distinction. You'll have guys that do a lot more physical labor than other ones, but everybody's going to have to really rely on each other. And I think that issues will get resolved fairly quickly. So let's say no unions for the first 100 years. Well, maybe 50 years, who knows? Because they're going to want to get their cut eventually. So with welding on Mars, that was one of the issues. I have I keep forgetting. I think we have 5 welders that work for us full time right now. And we pretty much fabricate everything that we build these days. It used to be, we would bring in people and hire subcontractors, but we ended up, in fact, I think we've got 3 union guys that quit the union that just work for us now. Anyway, so with NASA, with this, the spaceship they're building, God, I can't think of the name, forgot the name. That's mostly aluminum, hybrid aluminum. With SpaceX, he's using stainless steel. And from what I understand, it's 316 stainless. So it's got titanium in it and some other alloys, which makes it a bit trickier to weld because of the temperatures. The water systems are probably going to all be stainless steel, and the rovers will be titanium and stainless steel. Titanium is an interesting one to weld because especially on, I'll show you, this is one of my pictures. This is a guy working in our shop right now. You can see this stuff flying all over the place. One of the tricks with welding on Mars would be that the stuff will fly a lot further because of the less gravity. So you're probably going to have shields around these where they're welding, and you can see he has the mask on. That's another thing that you'll have to deal with. I mean, think about it. You're gonna have to have a space suit on, you know, let's say Mars suit, not space. You have to have a Mars suit on. It's gonna have to be pressurized. It's gonna have to be pretty tough, and it's also gonna have to have a lot of dexterity for the fingers. So that's a big deal, the dexterity especially. Is this right? I'm 23 minutes ready? Oh, okay, so I'm gonna wrap it up. Well, anyway, we're gonna have this would almost look like a Mars suit. You'd have to have a space shield, and you'd have to also have the suit be able to handle these sparks flying over the place. And electricity, you're gonna have to have electricity. What I read is most of the systems they're thinking about are either nuclear energy or solar with batteries. And I came across this number. Maybe someone could correct me if this is wrong, but they're saying it's going to add about 8.3 tons of weight to the spaceship to get the solar and the batteries up there for 40 kilowatts, which is what everybody has been mentioning as the number they want. Or it's 9.5 tons for the nuclear energy. 40 kilowatts won't get you very much welding done. That's the problem I would see you would have right out of the box. You'd have to have one of these set up strictly for welding. And, you know, you could, like we use 150 kilowatts on a smaller machine. So that'll be a trick. Now, one of the things I did run across for this is what I'm talking about there is arc welding. Turns out laser welding takes about 1/10 of the energy. So I'm guessing any welding that is done on Mars will be from laser welding. Plastic would be great because it's lightweight and it's easy to deal with, but it doesn't like UV. It's not very good handling extreme cold, and the dust storms would eventually erode it away. The advantage is it's lightweight. It can be made from bacteria, which I mentioned. What do you do with all the waste streams? And it's easy to work with. I found this picture and I thought this is pretty cool. That this would be what I would think the very first settlement would look like. Eventually, you want to cover these things with some kind of structure to keep the UV and the dust storms out. There's a typical rover. I'm not sure which one of that is, but that's mainly titanium and aluminum. So that would be what you would be welding on. This is a picture of welding titanium. Now, it looks nice. It's pretty with all the blue and stuff. The blue is actually contamination, and that's contamination comes from oxygen. So on Earth, we have little nozzles that flood the welding tip with argon. The melting point is about 1670 C, so you have to have it pretty hot. One of the tricks will be, how do you get that heat and make that weld, and then if it's in the atmosphere, it's going to instantly go down awfully quick. You know, it might be 100 degrees below zero. So that is going to be another issue when you weld on Mars. 3D printing is another way for building, and that's mainly for bricks. I read an article about how they'll use 3D printing to make bricks or structures. The problem that I see there is that you have to have a resin to bind this material from, the dirt and stuff. You can make those polymers from these things, vegetable fats, oils, cornstarch, straw, none of which would be available on Mars. So what do you do there? Well, there's some people at the University of San Diego that have been working on using E. coli, and they are able to make a type of plastic with that. So yeah, if somebody said, "Oh, that building is shit," well, they'd probably be telling the truth. They're on Mars. This is the image I saw of a 3D printed hab. I don't think it's realistic. And because I lost all my PowerPoint. I wanted to bring a few notes. So the other thing that's been happening at the University of San Diego is they found out that they use simulated regolith. And what they found was that if you just take a hammer and smash it, the pressure will force the iron oxide molecules to bind, and you could make bricks out of regolith just using pressure. So anyway, I lucked out. I got through it half an hour. I just wanted to give you guys some ideas what a construction worker is. Oh, thank you so much. Thank you. Thank you. And I can't wait to see you all on Mars.
Simon, for one question.
Yeah.
Oh, I want, yeah, oh, okay.
Oh, yeah, what type of laser would you be using for laser welding?
That's a good question. Does anybody else know? I don't know that much about lasers or laser welding. We haven't used that where I work. We mainly use arc welders. Yeah. If somebody's quick, you could Google it. It is on the internet. I saw that. I'm sorry, I don't have an answer for you for that one. Okay. Thank you.